All right, folks, we are going to be looking at 3.6, which is the last section. So after fall break, we will be working on a quiz, a test review, and a test. So you'll get a lot of points to start the second quarter. So we are going to look at exponents and scientific notation. Specifically, we're going to go over the properties of exponent, which is probably the hardest part of this we're doing today. And then we're going to look at scientific notation and go from scientific notation to decimal notation and back the other way. And then we're going to perform computations, which is basically these calculators handle scientific notation. So you'll be just putting stuff into the calculator, basically. So let's get talking about exponents. Here are the three major rules we have for exponents, right? So we remember that an exponent, if I have like 3 to the 4th power, and it would help if I had a 3 to the 4th. I wonder if we know the exponent tells us how many times we multiply that base by itself. So 3 to the 4th would be 3 times 3 times 3 times 3. Or x to the 3rd, we know would be x times x times x. So what we're going to talk about is we're going to be talking about multiplying these powers together. We're going to talk about dividing these powers. And then we're talking about taking a power to a power and finding the shortcut for that. So here are the three rules. The product rule, notice right here. Let me zoom in on it so you can see it real good. Is if I'm multiplying two powers together that have the same base, both of these, remember the base is the main number, the exponent is the number floating up to the right. If you multiply powers together that have the same base, the shortcut is you just add the exponents together. So 9 to the 6th times 9 to the 12th is the same thing as just adding that 6 and 12 together to get 18, and that is equal to 9 to the 18th power. All right. Now, most of the time on our assignments, if it's a number to a power, we could just punch that in the calculator. I could take 9 to the 6th times 9 to the 12th, hit enter, and it's going to give me that big long answer. So where it really comes into play is if I have variables. So if I have x to the 3rd times x squared, all right, I'm multiplying those powers. The bases are the same. They're both x. That means I can add their exponents. That's a total of 5 x's. Okay. Now, if it were x to the 3rd times y to the 2nd, I couldn't simplify that. All I would do is I would rewrite that without the dot. I would say that's x3, y2. Okay? So the base has to be the same if you want to add those exponents together. All right? Then we're going to look at the quotient rule or the power rule. Let's look at the power rule first. All right, here's the power rule. Notice the difference. I'm taking a power, putting it in parentheses, and then raising it to another power, or it's got an exponent raised to another exponent. Okay? In this case, the shortcut is to multiply, because 3 to the 4th to the 5th power, really what that means is 3 to the 4th times 3 to the 4th, 5 times, right? And then if you'll notice, I've got 5 of these 3's multiplied together, which means I could add their exponents. If I add 4 5 times, I get 20. So the shortcut, when we recognize that a power has been raised, so it's got an exponent to a raised to an exponent. It doesn't have separate bases. This second exponent doesn't have a base. All right, I'm going to multiply those. So 3 times 8 is 24. So if I had x to the second raised to the 7th, exponent to an exponent, power to a power, I multiply those 2 times 7 to simplify that to x to the 14. All right, so that's our power to a power rule. Then our last rule is the quotient rule, or when we are dividing. And multiplying and dividing are opposites. So when we multiply, we add the exponents. So when we divide, we subtract the exponents. So let's zoom in on this right here. If I have 5 to the 12th over 5 to the 4th, right? Now, if I were just typing that in the calculator, I would type it in just like that and it would give me the answer. But we're just worried about the exponents right here. Got to have the same base. If you have the same base when you're dividing, you can subtract. And you always subtract the top number minus the bottom number. So it's going to be 12 minus 4, which is where they get 8. The next one, 9 to the 40th power over 9 to the 5th. 40 minus 5 is 35. So if we were looking at variables, what I would look at is if I had x to the 7th over x squared. They both have a base of x, so I would subtract. 7 minus 2 is 5. Now, this is just like multiplication. If I had x to the 7th over y squared, then I couldn't do anything with that. It would just stay x to the 2nd over y squared. All right? So that is our 3 exponent rules. Now, here's one thing you need to remember. Anything raised to the power of 0 is equal to 1. Anything to the power of 0 is equal to 1. So if I have x to the power of 0, that equals 1. If I have y to the power of 0, that equals 1. If I have 752 to the power of 0, that equals 1. The only thing that raised to the 0 power that is not 1 is 0. You cannot raise 0 to a power of 0. It does not exist. All right? Anything else raised to the power of 0 is equal to 1. Okay? So please remember that rule. So notice right here, 7 to the power of 0 equals 1. Pi to the power of 0 equals 1. Negative 5 to the power of 0 equals 1. Okay? That's what we just said. Now, notice this one. This is very important as you're putting these things into the calculator. Notice negative 5 to the power of 0 is equal to negative 1 without the parentheses. Okay? If I do not put the parentheses right here, when I put these parentheses, let me change color. When I put these parentheses, okay, that means the entire number, negative 5, is being raised to the power of 0 and is equal to 1. If I do not put the parentheses, then it is only raising the number 5 to the power of 0. That negative is just going to sort of tag along with it. So you got to be careful when you put numbers in your calculator to a power, that if it's a negative number you're wanting to raise to a power, you have to put that negative number in parentheses. So what happens is the 5 to the 0 is 1, and then that negative just tags along with it. So that is very important to remember. All right, now, one more thing about exponents is you cannot have an exponent that is negative left in an answer. If you have an exponent that is negative, we have to do some adjustment to fix that. It is not simplified if the exponent is negative. Just like if you have 4/8, that's not simplified till you simplify it down to 1/2. And here's the rule with an exponent. Notice the variable b raised to the negative m is equal to 1 over b to the positive m. So here's the rule. If we have a fraction bar, all right, and we have something that is a negative exponent, I have x to the negative 4 in the numerator. If you take that power and you move it across the fraction bar, it changes the sign of the exponent. Okay? So if it's on top and I move it to the bottom, it changes the sign of the exponent. Notice if it was a positive x to the 4th on the bottom and I moved it to the top, it would become a negative. So x to the negative 4, I move the x, right? That can be written as x to the negative 4 over 1. I move the x to the bottom. It makes that a positive exponent. And since there's nothing left on top, I fill it in with a 1. All right. Notice these right here. If I have x to the negative 3 over y squared, notice if I move the y squared to the top, it becomes y negative 2. I moved it from the bottom to the top, so it changed the sign. If I take x to the negative 3 and move it to the bottom, it becomes a positive 3. Now, I would not work a problem like that because now I still have a negative exponent. So really what I should have done is left the y squared where it was at because it was positive and only moved the x to the negative 3 so that I end up with this answer right here. Okay? So what will happen is if I have x to the 3rd over x to the 7th, that is a division. So we said what we do when we divide, if the bases are the same, is we subtract. Always top minus bottom. 3 minus 7 is negative 4. So notice I'm left with a negative result there, which means I have to go one step further because I cannot leave a negative exponent. So this is like negative x to the negative 4 over 1. So I would move the x to the 4th to the bottom, and I would have that on top. Okay? So make sure we recognize that when we're solving these. All right, so here's just some of these to simplify. Now, if it is a number raised to a power, you can just punch it in the calculator. If I have 8 to the negative 2 power in the calculator, 8 raised to the negative 2 power, I get 1 over 64. All right, the calculator tells me it is equal to 1 over 64. Well, how did it get 1 over 64? Well, because that's negative, I've got to move it to the denominator. So that'd be 1 over 8 squared, and then we know 8 times 8 is 64, and that's where they get the 64. 5 to the negative 3 is going to be 1 over 5 to the 3rd, which is 1 over 125. But once again, if you have all numbers with no variables, you can just use your calculator. Punch it in your calculator, and it's going to tell you the answer. Okay? 7 to the negative 1 would be 1 over 7. Remember, if there's no exponent listed, it is understood to be 1. All right, so let's look at these examples here. I've already got the answers there, so we'll just step through it. Here, x squared times x to the 4th. I'm multiplying. So I add 2 plus 4 to get 6. That's where they get the 6. That's not a very good circle. 2 plus 4. Here, exponent to an exponent, that's where I multiply these two numbers. I'm going to multiply 3 times 4. That's where they get 12. Look at this one, x5 over x squared. Divide, I'm going to subtract. 5 minus 2. That's where they get the 3, right? 5 minus 2 is 3. Remember, if the exponents are different, x5 over y squared, I can't do anything with it. Now, let's get into a couple of these that are a little bit more complicated. And I'm going to rewrite this one over here. That is x squared y to the 4th power x y squared to the 3rd. Now, this one, it has got exponent to exponent, and it's got multiplication in it. So what you've got to do, order of operations say exponents are done before multiplication and division. So what I've got to do is this right here in parentheses is raised to the power of 4. That means both of these are raised to the power of 4, which means I've got to multiply both exponents by 4. So 2 times 4 would give me x to the 8th. And y, that's an understood 1. 1 times 4 is 4. So I would have just this is going to simplify to x8, y4. Over here, same thing. I've got y, x1, y2. So 1 times 3 would be 3. So that's going to be x3. 2 times 3 is 6. So I've gotten rid of my exponent to exponent. Now I have to multiply, and I like bases, I add them now because I'm multiplying, right? There's 2 bases of x. So I add 8 plus 3 is 11. So that's going to be x11. And then 4 plus 6 is 10. So that's how that goes. Then let's look at this one right here. I'm going to rewrite it over here also. X squared y over x y4 to the negative 2. All right. So this one, we've got x squared y over xy4 in parentheses raised to the negative 2. So remember our order of operations. Our order of operations say do everything in parentheses first. Okay, so inside that parentheses, I can simplify by division there before I do my exponent. So what we're going to do is we're going to subtract. X is 2 minus the understood 1 is 1. So I've got x to the 1st. Y, that's an understood 1. Y minus 4. If you need a calculator, that's fine, but that is negative 3. And then that's been raised to the negative 2 power. Now what I have left is an exponent to an exponent. So I've got to take that negative 2 and I've got to multiply it by both exponents of both the x and the y. And so what I have is x has an understood 1. X, 1 times negative 2 is negative 2. And then y, negative 3 times negative 2 is positive 6. Now, I can't leave that because I have a negative exponent. I only have to move the base that has the negative exponent, which means I only have to move the x. So that's going to, the y6 is going to stay in the numerator, and the x squared is going to go to the denominator to get rid of that negative. All right. So that's sort of all the things that go into this. All right. So I think next is the all right, powers of 10, which we're talking about powers of 10 here in a minute because of scientific notation. A positive exponent tells how many zeros follow 1. So, for example, if I had 10 to the 25th power, and this only works for 10, that answer would be a 1 with 25 zeros. Okay? If you multiply 10 by itself 25 times, you would get a 1 with 25 zeros. If I have 10, right? We know 10 to the second, right? Is 100. Well, look, that's a 1 with 2 zeros. All right? A negative exponent tells how many places there are to the right of the decimal point. So if I have 10 to the negative 7, all right, it tells me that there are now negative or 7 numbers to the to the right of the decimal point. Now, that doesn't mean 7 zeros because you have to include the number 1 because you're moving it back to the, so what it is, the way it works is it's actually 1 less than this zeros. That would be 6 zeros. And the 1 counts as the 7th spot. Like right here, 10 to the negative 9 would be 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8, with the 1 being that 9th spot. So if I had 10 to the negative 300, that would be a decimal and 299 zeros before a 1, right? So let's apply this to scientific notation. All right, right? Y'all have seen scientific notation or exponential notation. This is a way to write very, very large numbers or very, very small or very, very large decimal numbers without having to write out 100 zeros or 60 zeros or something like that. Now, here's what you need to understand. Notice how these 3 numbers are written right here. The only one that is written proper for scientific notation is this one right here. When you are writing scientific notation, the first number has to have 1 number to the left of the decimal. No more than 1, no less than 1. See, this one does not have anything in front of the decimal or an understood 0. That's got to be a non-zero number. This one has 2 digits in front of the decimal, so that is incorrect. So this one is the proper way to write scientific notation. And now, what does that mean? 2.35 times 10 to the 5th basically means, what does that equal? Well, positive numbers, that's like multiplying by 10 5 times, or multiplying by a 1 with 5 zeros. That basically, because we're in base 10, that moves that decimal this many times. So that number written would be 2, and then I would move the decimal over 1 time, 2 times. Now for the rest of the 5, I don't have any numbers there to move it next to, so I just add zeros. So it goes from there 1, 2, and then 3, 4, 5. So 2,300 or 235,000 is that number. Now on our calculators, there's a little times 10 to the nth button that's right in the middle of the top, the 3rd row down right in the middle. And that will allow us to write scientific notation. And as long as the number's not too big, you can hit enter and it will transfer it. Okay. So let's look at, if I want to write each number in decimal notation. So decimal notation means without the times 10 to whatever. So if I have 1.375 times 10 to the 10th, that means this right here, the positive 10 is telling me how many spots I've got to move that decimal to the right, 10 spots. So if it starts right there, 1, and then I move it over once, twice, 3 times, but I got to go all the way up to 10, so I got to fill in zeros. 4, 5, 6, 7, 8, 9, 10. So that is 13,750,000,000. All right. Now, when it's a negative number, all right, that means we move the decimal back the other direction. that many spots. And remember what we said earlier. That doesn't mean there's going to be 4 zeros. That means there's going to be 3 zeros and then this 1, because that decimal has to count, that 1 takes care of one of my movements. So 1.1 times 10 to the negative 4th means 3 zeros and then whatever's right here, 1, 1. So notice if the decimal was originally there, it's moved back 4 spots. So a positive 10, you move that decimal over that many spots. Once you get to the end of the actual numbers, if you still have to go, you just fill in zeros. The way it's set up, when it's a negative number, there'll always be 1 less than that number of zeros before that number. Now, what if we want to go the other direction? All right. I want to write each number in scientific notation. Well, here's what I've got to remember. I've got to take the decimal, which if there is no decimal, we know it's right there to the right. That decimal has to move to where there is 1 non-zero number to the left. So that means this decimal has to move to right here where that comma is. So when I write it, it's going to be 4.6, and then I can drop off all the zeros that trail it. Now, how many times did I move that decimal? Well, this is where I've got to count. 1, 2, 3, 4, 5. I moved it over 6 spots. So that's 10 to the 6th, right? This one, it's a decimal. So I got to get that decimal moved over to where there's 1 non-zero number to the left of it, which means this is going to be 2.3. Now, how many spots did I move that decimal? I moved it 1, 2, 3, 4, 5 spots. And remember, that's coming from a decimal. So that's going to be 2.3 times negative, or 10 to the negative 5th. All right. So not very difficult. Y'all been doing that for a while. Now, what we're going to do is problems like this, we're just going to type it in the calculator just like it's written. I'm going to use that button I just told you about. I'm going to use the parentheses. So I would say 3.4 times 10 raised to the 9th. Make sure you arrow out of that exponent before you put the parentheses. And then 2 times 10 to the, hit that little button, times 10, whoops. 2 times 10 to the negative 5. Hit enter, and that's 6,800. It says in decimal notation. So the answer is 6,800. If I did want to write that in scientific, remember that decimal would have to go right there to make that 6.8. And then it's moved 4 spots, so that would be 10 to the 4th. All right. If you were wanting to do it by hand, what you would do is you would multiply 3.4 times 2, which is 6.8. And that's in proper scientific notation. And then I do my exponents right there. I'm multiplying 10 to the 9th times 10 to the negative 5th. So I would add 9 and negative 5, and I would get 10 to the 4th. Notice I get the same thing. If I had gotten a decimal right here, 68, then I would have had to move it back 1, which means I'd have had to add a number there. If I'd have got 0.68, I'd have had to move it forward, which means I'd have had to subtract 1 from there. But we're just going to use the calculators. Same thing with dividing. I just put it in as a fraction, and the calculator, I think we can all handle that. So I think that's it.